Hi guys, in this specific video we're going to look at the concept of vector subtraction, and that is going to of course assist us complement on the first two videos on the parallelogram rule that we had seen for vector addition and the head to tail concepts that we were looked in our first case. So if I consider this specific aspect for two vectors for A and B, we just give them as this one A and B, and these vectors are joining one another at the origin point, which I've given as O. If we try to perform an operation that is going to entail the concept of subtraction, whereby we're going to subtract B from A, so this is A minus B, and then this is going to, of course, be illustrated. We are saying so that we can be able to obtain a resultant vector by translating one, or rather trying to change one of the vectors for B, perhaps removing A parallel to its specific from its original point. So we're going to obtain a resultant vector that we say is going to be C. So suppose we have this specific case whereby C is equivalent to A plus B, and if we try to subtract B from A, then therefore this is going to imply that our resultant vector is going to be an operation that is going to consist of a negative value of B given as such. So therefore we can be able to describe this specific vector and try to see what effect it's going to have on the resultant vector in this specific case. So we are going to have it using this second figure, which we can be able to illustrate as such. So suppose our point of origin is as this specific point, and we had our vector, this is our vector A and B. So this is A and B. And if we are going to subtract this vector B, we're going to see that it's going to maintain its magnitude, as we had said in our first case for the scalar multiplication of vectors. It's going to maintain its magnitude, but the effect of the negative sign this here is going to of course change the direction in the same magnitude of those. So suppose it was a unit vector for A, for B, then B we are going to see that it's going to change its direction due to the negative sign, and we're going to have a negative unit in terms of its magnitude. So therefore we can be able to represent this specific resultant vector considering that B is going to be considered in the negative direction using that, whereby we are going to of course consider this by trying to find or rather trying to move this vector in the parallel direction towards B, which is going to give us of course another vector at the tip of this one, of course, which is vector A. So we have moved vector A from this specific point to this one. Therefore, it's going to give us a resultant vector that can be described as C in that specific direction given as such. So for us to find C, then therefore, we're going to see that C is going to be a result of vector A minus vector B, which is going to be given as vector A and then minus vector B given as such. So therefore this is going to be referred to what we call a resultant vector. And of course, among others, we have seen that some basic rules for subtraction of vectors are going to follow the rules of addition, only that the difference for this, for the negative sign, it's going to change its direction as we have already indicated. So in this case, we can consider a case whereby suppose we had a particular this specific point, and this final point is going to be at this specific point, and therefore we can move in the direction of negative B. So we can describe from O to A, which is a vector quantity of this C, so which is O to A, which basically is vector C. We can be able to describe that one as negative B, and then we're going to have positive A represented as such. So this specific description is a rearrangement of this formulae that I've given at the lower part of our board. So in some cases we're going to see that if the differences in vectors is 0, then therefore they are going to be regarded as identical. So in this case, if I say that vector A is equivalent to B, then this implies that the two vectors are identical or equivalent, and their specific equation, then therefore the subtraction for this A minus B is going to be given as 0. So this is some basic operation that we're going to see being applied in vector subtraction. And of course, we have said about the few rules which we had mentioned for addition and scalar multiplication of vectors, for the associative, distributive, and of course, the other one that we have mentioned in our previous discussion. So in this case, I wrap up there, and I hope that we are going to check in our description boxes for various links for similar videos that we have discussed on the same, which are going to assist us, of course, compare this and of course, try to create a contrast between various procedures that we can use for addition and subtraction, or rather the general concept of vector algebra. So that is it for now, guys. Bye, God bless you. Catch us in our next video.